is given by the magnitude of the charge, that is plus q. Okay,
Yes, sir.
simply you can write here plus q, and velocity of the particle cross magnetic field vector. With this formula I have written in the vector. Now I can write this formula in the scalar form also. Scalar vector form means this formula will give you the direction as well as the magnitude. Direction as well as the magnitude.
Yes, sir.
Direction means east, west, north, south, x-axis, y-axis, z-axis.
Yes, sir.
Negative x-axis, negative y-axis, and negative z-axis. All these things represent the direction. On the same way, if you have suppose force of 10 Newton, so this 10 will be the magnitude of the force.
Yes, sir.
Suppose
Yes.
I am saying 10 Newton along x-axis. So x-axis will be the direction and 10
Yes, sir.
Newton will be the
Magnitude.
magnitude of the force. So for the vector, if you have two vectors, suppose you have written this A vector, this is A and this represents the vector, cross
Yeah,
B
sir.
vector, A vector cross B vector. And now if you want to open this cross product, this represents the cross product. So if you will open the cross product, then you will write A. A means the magnitude only of A vector, and
Okay, sir.
B represents the magnitude of B vector and
Yeah.
sine theta. Sine of theta, and theta is the angle between A vector and B vector. In the same way, you can write the force here, this Q. When you open this cross product, this will become V sine theta.
Sine theta.
And what
Yes,
is
sir.
theta? Theta is the angle
Angle.
between the velocity vector and the magnetic field. So here
Okay,
in
sir.
this case, the vector is involved. Okay.
Okay, sir.
We have discussed now this already.
Yes, sir.
This thing I have discussed the work done by the magnetic Lorentz force. I think I have discussed or not?
Yeah, I think we did, sir. Yeah.
I have done. So, this thing, charge part of the.
No, sir. I don't think you did, sir. No.
I mean, last part I have completed that work done.
Yeah,
Okay,
sir.
so okay. I think I have to teach this.
Yes,
So
sir.
now you are in a magnetic field. We are studying the magnetic field and our charge
Sir?
particle. Yeah.
Your voice is breaking, sir.
Okay, just a minute. Ziyad, now it's fine.
Yes, sir.
You can tell me if my voice is breaking. So
Okay, sir.
now we will see if the charge particle will move in the magnetic field, then what will be the path of the charge particle? What will be the path of the charge particle? So this is your heading, path of the charge particle in magnetic field. When
Okay.
the charge particle is moving in the magnetic field, then which path? Path means the straight line path. The path can be the circular path. The path
Yes,
can be
sir.
the parabolic path. Okay. So here is this charge particle, and this is the velocity of the charge particle, and this is the magnetic field. Means this charge particle is moving in this magnetic field. So you can see the direction of the magnetic field and the velocity is same. In this case, if two things have the same direction, if two vectors have the same direction, because velocity and magnetic field both are the vector quantities and they have the same direction, so the angle between the magnetic field and the velocity vector will be 0 degree. So now what we will do, we will just find what will be the magnetic force, as this charge particle is moving in the magnetic force. So this charge particle is moving in the magnetic field. So there must be a magnetic force on this charged particle, and value of that force we will calculate with this formula. Is it now? There will be some magnetic force on this charged particle
Yes, sir.
because this charged particle is moving in the magnetic field. The formula is this. In the vector form, this is written as Q V cross
Yes, sir.
V.
Yes.
And when you will open this, you will get the scalar form. This will be Q V sine of theta.
Yes, sir.
So now we have charge, we have velocity, we have magnetic field. Sine, instead of theta, put 0.
0. Yes, sir.
And you will get sine 0 is equal to 0. Sine
Yes, sir.
0 is equal to 0. So this whole thing will become 0.
Yes, sir.
Because see here, this sine 0 is 0. 0 multiplied by anything will be 0.
0. Yes,
So,
sir.
so you can say when the charge particle is moving parallel to the magnetic field, then there will be no force on the charge particle. There will be no force on the charge particle. Now suppose if your charge particle is moving in the opposite direction of the magnetic field. This is
Yes,
your
sir.
charge particle and this is moving with a velocity this, but now you can see the angle between this velocity vector and the magnetic field vector will be 180 degree because both the vectors are in opposite direction. So here also
Yes,
you
sir.
will get F is equal to QVV sine theta. So you have charge, same charge is moving, and this is
Yes, sir.
velocity and V, and this will be sine 180 degrees. Sine 180 degree is also 0. Sine 180 degree is also 0. So again, the value of the force will be 0 on the charge particle. So you can say that whenever the charge particle is moving parallel or anti-parallel to the magnetic field, then the net force or the magnetic force on the Lorentz magnetic force on the charge particle will be 0. So suppose if anything is moving, along the straight line and no force is acting on that thing, so the body will continue its motion in the straight line. Okay, so same
Okay,
is
sir.
the case with the charge particle. This charge particle will continue to move in the straight line. Okay,
Okay, sir.
because there is no force on the charge particle. So you can say here, no magnetic force acting on the charge plus Q. We know that. Hence, no charge in path, and no change in path. No change in path means there will be no change in path. Earlier, the
Yes, sir.
path is the straight line. Then again, the charge particle will follow the straight line. Simple.
Yes, sir.
Okay. Now, if your charge particle is moving 90 degree to the magnetic field, if your charge particle theta is equal to 0 and theta is equal to 180, we have discussed. Means the charge particle is moving parallel and anti-parallel. Now, if your charge particle is moving perpendicular to the magnetic field, so this charge particle will have a velocity in this direction. So
Yes, sir.
remember in that case, the charge particle will follow the circular path. In this case, the charge particle will follow the circular path. Charge
Okay.
particle moving perpendicular. This sign represents the perpendicular to magnetic field. The path will be circular. Okay. So, see here now, this case. In this case, this cross means the magnetic field is inwards.
Yes, sir.
We have already discussed. You can write inwards magnetic field. Inwards means along negative z axis,
Okay, sir. Yeah.
means into your screen. Something
Yes, sir.
means
Yeah.
magnetic field lines are going into your screen. If magnetic field
Yes,
lines
sir.
are coming from your screen towards me, coming from my screen towards me, then in that case I can say the magnetic field is outwards. Okay,
Yes, sir.
along negative z axis. So this is very simple thing. So this is suppose your charge particle Q, and this charge particle is moving in the magnetic field. This charge particle have started the motion from this point, and this charge particle is moving in this direction, means the charge particle is moving along x-axis. No,
Yes, sir.
and magnetic field is along z axis.
Yes.
So you can say the angle between the velocity and the magnetic field will be 90 degree. So here theta will be 90 degree. So what will happen? Suppose this is the charge particle moving in this direction. So the force on the charge particle will be in this direction towards the y-axis. How? Just what you should do. If you want to find the direction of this force, I think in the last class I have told you how to find the direction. So for finding the direction of the force on this charge particle, how this direction of force is like this. So point your four fingers along velocity.
Yes,
Point
sir.
your four fingers along velocity and curl your four fingers towards the direction of magnetic field. So this is the inward direction. Inward
Yes, sir.
direction is
Inward
something
direction.
going away from me is inward. So I am
Yes,
just
sir.
curling my fingers inward direction. So direction of the force will be like this.
Yes,
Here,
sir.
see here. So if the particle will be at this point, then the magnetic force on the charge particle will be along this direction. So now
Yes, sir.
suppose
Upwards.
charge particle is here. Here is your charge particle. Then if the charge particle is here, then here also the velocity of the charge particle will be in this direction. Okay, because
Yes,
charge
sir.
particle always try to move in the straight line. So the
Yes,
velocity
sir.
of the charge particle will be in this direction. So there will be some force on the charge particle as the charge particle is in the magnetic field. So direction of the magnetic field will be given by right hand thumb rule. Just point your finger along the direction of the velocity and
Yes, sir.
curl your finger towards the magnetic field. This direction. Point your
Ye-
fingers along the direction of the velocity and curl towards the magnetic field. Magnetic field is inwards, so this will be the direction of the magnetic force. So here, if the charge particle suppose is here, then on this charge particle the magnetic force will be in this direction. So this will be the direction of the magnetic.
Yes, sir.
So that is why the charge, so you can say the force on the charge particle at each and every point will be along the center. Charge particle is here, the force is in this direction, and charge particle is here, the force is in this direction. So you can see the force is along the center of the circle. So that is why this charge particle will acquire the circular path in the magnetic field when the charge particle is moving perpendicular to the magnetic field. And I have supposed here the radius of the path followed by the charge particle is capital R. And also here the force you will get, magnetic force, this is also perpendicular to the velocity or also perpendicular to the magnetic field. And how this force is perpendicular to the magnetic field? Because I have told you earlier that from this formula I will get this. This is the cross product I have told you here. Direction of the magnetic force will always be perpendicular to the direction of the velocity. Okay. And
Yes, sir.
also perpendicular to the direction of the magnetic field.
Yeah.
So here your force will be perpendicular to the velocity of the charge particle and perpendicular to the magnetic field. Simple. So you can say, and one thing more, there is a term centripetal force. There is a term centripetal force. So centripetal force is a force required by the body when the body to move in a circle. When the body have to move in a circle. If you are moving in a circle, for the you can say for the circular motion, the force requirement is the centripetal force. Without the centripetal force, you cannot move in a circular path. So here this
Yes,
charge
sir.
particle is moving in a circular path. So there will be some centripetal force on this circular path, on this charge particle. So centripetal force will be provided by some other force. Like if the charge particle is moving in a gravitational force, if a charge particle is moving in a gravitational force on a circular path, then on the circular path the centripetal force is required, and that requirement will be fulfilled by the gravitational force. But here your charge particle is moving in a circular path, and which force is available here? Magnetic force. This is the magnetic force, no?
Yes, sir.
So magnetic force is available. So this magnetic force will provide the centripetal force to this charge particle. So centripetal force required for the circular motion, which is provided by the magnetic force. Okay. And this is QVV,
Yes, sir.
because we have already placed theta is equal to 90 degree, and this is the magnetic field, magnetic force QVV sine 90. Sine 90 is 1. So the magnetic force acting on this charge particle is Q into V into V, because this charge particle is perpendicular to the magnetic field. And the formula of
Okay.
the centripetal force, if a body or a particle is moving on a circle, is mass of the particle is square of the velocity divided by the radius of the that circle. So you can say mb square by r. This force, centripetal force, is equal to the magnetic force. Okay. This is the centripetal force, and this is the magnetic force. So this is your magnetic force. This force is your magnetic force. And this is your centripetal force. So centripetal force will be equal to the magnetic force in this case. And when you will calculate the radius r, okay, here from here this v and v will be cancelled out. This v and v
Yes,
will
sir.
be cancelled out. So radius will be mb by qv. So you should learn this formula. Radius of the circular path in the magnetic field.
Yes, sir.
This will be given by the mass. M represent the mass of the particle. V represents the
Okay, sir.
velocity of the particle. Q represents the charge, and V represents the magnetic field. So
Okay, sir.
M is mass, V is the velocity, Q is the charge, and V represents the magnetic field. Now you will assume, you will see here this charge particle is moving in a circular path. This charge particle is moving in a circular path. So whenever a
Yes,
body
sir.
is moving in a circular path, then if time taken to complete the circle, time taken to, there is some time to complete the full circle. Suppose the charge particle has started its motion from this point, and charge particle is moving like this, and finally the charge particle at this point, means this charge particle has completed the one circle. So time taken by the charge particle to complete one circle is known as the time period. Time period, and that time
Yes,
period is
sir.
given by this time period. Time taken by the charge particle to complete one revolution of the circle while moving in magnetic field. MF represents the magnetic field, and this time period uh, can be calculated with this formula. Speed is equal to distance upon time. Okay, speed is equal to distance upon time. And what is speed? Speed is just the magnitude of the velocity.
Yes, sir.
Speed is magnitude of velocity, because speed is a scalar quantity and velocity is a vector quantity. So
Yes, sir.
speed is the magnitude of the velocity. So what we have, we already know that speed is equal to distance, speed of the particle equal to the distance covered by the particle divided by the time taken by the particle to complete that distance. So speed of the charge particle is v, distance covered by the charge particle. Now charge particle is moving from this point to this point again. So distance covered by the charged particle will be 2 pi r. 2 pi r means whole circle.
Yes, sir.
If you are covering the whole circle, then you have covered the distance of 2 pi r, that is perimeter of the circle. So you
Yes,
can
sir.
write here v is equal to, here you will instead of this distance you will write 2 pi r, 2 pi into capital R, and time taken by you is capital T. Okay, so from here you can calculate the time period, that will be equal to 2 pi r by v, 2 pi r by v from this equation. So you can write 2 pi by v, instead of this r you can put this value mb by qb.
Yes, sir.
This will be mb by charge into magnetic field. This v and v will be cancelled out. So the formula of the time period will become 2 pi m divided by qb.
QB. Yes, sir.
This is the time period. Now there is one more term here, frequency. Frequency is the 1 upon time period. Frequency is 1 upon time period.
Time
Or
period.
if you define the frequency, if you want to define the frequency, then frequency is defined as the time, the number of revolution made by the charged particle in 1 second is the frequency. The frequency is represented by small f, number of revolution made by the particle in 1 second, and frequency is 1 upon time period. So can we find out the formula of frequency? 1 upon time period, and time period is given by 2 pi m divided by charge into magnetic field. So from here you will get the formula 2v divided by 2 pi m. So this is the small f. So these are some simple and basic things you should know. Frequency is this. Now, as this particle is moving along the circular path, so like if the particle is moving on a straight line, then the particle will have the linear velocity. That is, this velocity and the linear velocity are same. Okay, velocity and the linear velocity are the same thing.
Okay, sir.
But there is one more term when
Yes,
the charged particle is moving on a circular path, angular velocity. Angular velocity. Okay, and when
okay,
the
sir.
charged particle is moving on a circular path, then linear velocity is also there. This is the linear velocity of the charged particle. If you will draw, if suppose if this charged particle is moving in a circular path, and if you want to find the direction of the linear velocity, suppose here you want to find the direction
Yes,
of
sir.
the linear velocity. So what you will do, and the condition is that the charged particle is moving along the circular path. So you will draw the tangent along this circle at that point, then you will get the direction of the velocity of the charged particle. This thing you should remember. And now I am talking about the angular velocity. Angular velocity is given by 2 pi into frequency. This is angular velocity. 2 pi, and this angular velocity is represented by the omega. Like the linear velocity we have now, v represented by v. Angular velocity for the circular motion is represented by 2 pi f. So omega is equal to 2 pi, and the formula of the frequency we can put here. This is frequency, qv
Yes, sir.
divided by 2 pi m. So right here qv divided by 2 pi into m. So now this 2 pi and 2 pi will be cancelled out. So finally you will
Yes,
have
sir.
the angular frequency, that is omega, is given by q into v divided by m. So this is the formula of omega, that is angular frequency. Now there is one more term, kinetic energy. So what would be the kinetic energy of the charged particle moving on a circular path? The formula of the kinetic energy is given by, kinetic energy of any body, any particle is given by half m v square. Half m v square. As this
V
is the
square.
particle, as this is the particle, this particle is moving. So we will take the mass of this particle, half into mass of this particle into velocity square or the speed square.
Yes, sir.
So kinetic energy of a charged particle in magnetic field. So Kinetic energy is given by half mv square of the charge particle. This v square we will put from this equation. From the equation of r, you can calculate the value of v. This is now so simple. R qv divided by m. This is r qv divided by m. So you will put the value of this v from here, that is q v r divided by n, and square of this, because this is the velocity q v r by n, and square of this. So you will get half m into 2 square v square r square divided by m square, and from here m and m will be cancelled out. So finally you have the kinetic energy half of 2 square v square r square divided by m. So this is the formula for the kinetic.
Okay, sir.
Okay, now one by one take the screenshots.
Done, sir. Done, sir.
Again,
Done, sir.
okay. Time to get completed.
Yes, sir.
So now when the charge particle is moving parallel to the magnetic field, in that case, what will be the path of the charge particle? When parallel to the magnetic field.
Sir, can you repeat, sir?
I am saying when the charge particle is moving parallel to the magnetic field, what will be the path of the charge particle? See this case. This here the charge particle is moving parallel to magnetic field.
Yes, sir.
Here the charge path of the charge particle is straight line.
Yes, sir.
And when the charge particle is moving perpendicular to magnetic field, the path of the charge particle is
Circular.
circular.
Yes, sir.
This thing you should. Okay, now I will discuss one question regarding this. So for this, I will use this formula. Very simple question. This is the question. So they are saying in this question, a proton, a deuteron, and an alpha particle enters in magnetic field. So there, and proton, deuteron, and alpha particle are the charge particle. They are
Yes, sir.
entering in the magnetic field, and in the same magnetic field they are entering. They are saying calculate ratio of their radii. Means we have to calculate the ratio of the radius when they are entering with the same velocity, same momentum, same kinetic energy, and accelerated through same potential difference. So here this data is given. For the proton, the mass is this 1.6 into 10 to the power minus 27 kg, and mass of the proton is represented by m suffix p.
Yes, sir.
Charge of proton is given by this q, and you will represent the charge on proton with small e, and charge on proton is 1.6 10 to the power minus 90 coulomb.
Okay, sir.
Now one by one we will solve. So answer first. As this charge particle is entering to the magnetic field, so they are asking the radius of the magnetic field, means this charge particle will move in a circle. So we should know what is the formula of the radius. So this is the formula for the radius of the charge particle. So they are saying the The charged particle is moving with same velocity, same velocity. So if three particles is moving with the same velocity in a is entering in a magnetic field with the same velocities, and you can say uh, here the radius will only depend upon the mass and the charge, the ratio of mass and charge. Why I am saying this? Because for uh, three charged particle we have, the velocity is same and the magnetic field is same. So this thing will become independent.
Yes, sir.
Means the radius will only depend on mass of the charged particle and charge on the charged particle, not on the velocity and the magnetic field. Because we want to find the ratio. Okay. So here you can say the radius of the charged particle is depending upon the mass of the charged particle and the charge on the charged particle. So I will calculate the ratio now with the help of this equation. So radius of, they are saying proton, ratio, radius of deuteron, ratio, radius of alpha particle. This ratio we have to calculate. So radius of proton, from this formula I can write mass on proton divided by charge on proton. Radius of deuteron is given by
Yes, sir.
mass on deuteron divided by charge on deuteron. This ratio, mass on alpha particle, charge of alpha particle, mass of alpha particle, charge on alpha particle. So one by one we will put the value and we will get the answer. Mass of proton, mass of proton is represented by mp. Okay, I am just copying this table here. Now you can see in the table here, mass of proton is mp. Simply now put this value in the formula. Mass of proton is mp and charge on proton is e. This, so you will write charge on proton e, and
Yes,
ratio
sir.
mass on deuteron is 2 times of mp
Yes, sir.
and charge on deuteron is e.
Yes, sir.
In the same way, you can write mass on an alpha particle 4 times of mass of proton and 2 times of charge on proton.
Yes, sir.
So now this m by e, mp here, mp by e, mp by e, and mp by e will be cancelled out. So what will
Yes, sir.
be remaining here? 1. Here 1 is remain, and here 2, and here what will remain? 4 by 2. Because this thing and this thing and this thing will be cancelled out. So here you
Yes,
will
sir.
have 1 only, you will have, here you will have 2, and here you will have again 2,
Oh,
because this 4 by 2,
okay.
4 by
Yeah.
2 is
Yes,
2.
sir. Yes, sir.
So this is your final answer.
Okay, sir.
So now second part. You will see the value from the tables. Answer number second. In the answer number second also, they are asking same, the ratio of the radius. But one, according to the condition, we have to find. This we have to find. But first we should see what is given for the condition. Say momentum. Momentum. So what is momentum? Momentum is mass into velocity. Mass into velocity is the momentum.
Yes, sir.
So this time this momentum will remain same. This momentum will remain same, and magnetic field is also same because all the three particles are moving in the same magnetic field. So here also you can say that here your velocity is same and also the magnetic field. So that is why this V is same and this B is same. That is why this radius is not depending on this V and B. Here, what is same? This MB is same and this B is same. So
Yes, sir.
radius, formula of radius will be MV by QV. So you can say radius will depend upon only this charge, because
Charge,
this
sir.
this MB will be same for the three particle and
Yes,
the
sir.
magnetic field will be same for the three particle. So you will write 1 upon 2.
Yes, sir.
So now find the ratio of proton, deuteron and alpha particles. So proton, deuteron and alpha particle. So this is only depending upon charge. So I can write radius of proton can be written as 1 upon charge on proton ratio, 1 upon charge on deuteron, 1 upon charge on alpha particle. So 1 upon charge on proton is E, 1 upon charge on deuteron is again E, charge on alpha particle is 2E.
Yes, sir.
Now this 1 by E and 1 by E, 1 by E, or you can say E will be cancel out.
Yes, sir.
So you will have 1
By
ratio 1 ratio 1 by 2. This is the ratio. Now for the simplification, if you want to convert this ratio in the whole number, then what you will do, you will multiply 2 with this ratio, and this with this value, and this value.
yes, sir.
So this will become 2,
Yes, sir.
2, and this will become 2 by 2. So finally, you will have 2
So one right, sir.
ratio. Yeah,
Yeah.
this is 1. Is it or
Yes, sir.
not? This is 2
Yes,
and
sir.
this is 2. This 2 and 2 will be cancelled out.
Yes, sir. Yes.
So I have converted this ratio to this by
Okay, sir.
multiplying 2 like this.
Okay, sir.
Now, third part, same kinetic energy they are saying. Same kinetic energy. So kinetic energy is given by half m v square. Okay. Kinetic energy is given by half mv square. And here k represents the kinetic energy. So if I am multiplying and dividing with m and m, there will be no change.
Yes, sir.
If I am multiplying with m and again dividing with m, there is no change in this equation. There will be no change in this equation. So I can write this kinetic energy half. This m and m will be m square.
Yes, sir.
And here is also the b square. So you can
Yes, sir.
write this will become mb whole square divided by m.
Yes.
And this mb is the momentum. Okay, this mb is the momentum. So you
Yes,
can
sir.
write this this equation, you can write in this way also. You can just calculate mb from here. Mb square is given by, this is 2m into k. 2mk. So
Yes,
when
sir.
you will calculate the value of mb, it will become 2mk, and k represents the kinetic. So why I am doing this? Because I know that the radius of the charged particle is given by mb by qv. mb by. Now I will put the value of mb here. So when I will put the value of mb here, it will become 2m into k, and this will become charge into magnetic field. Now they are saying the kinetic energy is same and the magnetic field is same. So your k is same this time for three particles given. Magnetic field is also same, but the
Yes.
charge and the mass will be different. So your radius will depend upon this b will be removed from here, and this k will be removed, and this 2 is the constant. So I can write the radius will be depend upon mass, under root of mass, because here is under root. This will be removed.
Yes,
This will
sir.
be removed, because
Yes,
this
sir.
will be remain same for all of the three particles, and this will be remain same, and this will remain same. So and the magnetic field is also removed. So this will be this. So the ratio of the radius will be like this. You can write here. Radius of proton ratio, radius of neutron ratio, radius of alpha particle. This is given by mass of proton divided according to this equation. Now write according to this equation one by one. Charge on proton. Okay, ratio mass of neutron divided by charge on neutron ratio mass of alpha particle divided by charge on alpha particle. Mass of proton is under root E, not under root E. Mass of proton is mp and charge on electron is E.
Yes, sir.
Mass of neutron is, see from the table, mass of neutron is 2 times of mass of proton.
Yes, sir.
So I can write 2 times
2
of mass of
MP.
proton,
Yes, sir.
and charge will E.
E, sir.
This will be 4 times of mass of proton.
Yes, sir.
Mass of proton divided by
E.
2 times of,
2,
this time
yeah, 2.
your charge will be 2 times of charge on electron.
Yes, sir. Okay.
So now we will cancel out this MP and MP and MP will be cancel out under root of
Yes, sir.
MP. So you can write this as this MP divided by E. You can write this as MP multiplied by root 2 divided by E. You can write this 4 under root of 4 will become 2.
Yes, sir.
MP into 2 and here is 2. So now this MP will be cancelled out from all of the 3.
Yes, sir.
And this E and E will be cancelled out. And
Yes,
this here the 2, this 2 will be cancelled out. This MP cancel out, E will be cancelled out. So finally you will have the answer. Here
root
1, here will be 1 only.
Yes, sir.
Here will be root 2 and here is again 1.
1.
1 ratio root 2 ratio 1.
Yes, sir.
So this is your final answer.
Sir, can we simplify the root also? Or is it okay till here? Yes,
this is okay because we cannot further simplify it, because if you want to simplify it, so suppose if you are multiplying it with the root 2, because you have to
Yes, sir.
simplify this root 2, so you will multiply with root 2, so this root 2 when you will multiply, so this thing will become root 2, but this thing will become 2 and again this thing will become root 2, so it is better
Okay,
to write
sir.
in this form.
Okay, sir.
That is why I am asking.
Okay, sir.
So this is our and the fourth part I am giving you as a homework, and but I am giving the hint to you. The formula of the kinetic energy is charge into potential difference. Potential difference I am representing with PD. PD is the potential difference. PD means potential difference. So this is the hint, and you should try this by yourself. This is your okay. Now you can take the screenshot.
Okay,
So
sir.
you have to calculate the ratio.
Done, sir.
Done.
Yes, sir. Done, sir. Done, sir. Done, sir.
So we have seen the case that when the charged particle is moving parallel or anti-parallel to the magnetic field, the path will be straight line. When the charged particle is
Yes, sir.
moving perpendicular to the magnetic field,
It
the
will be
path of the
circular.
charged particle will be circular. Now we
Yes,
will
sir.
see if the charged particle is moving at some angle theta, and that theta is not equal to 90 degree, not equal to
Yes, sir.
180 degree, or not equal to 0. Means this time the charge particle will not be perpendicular, parallel, or anti-parallel. There will be some different angle.
Okay, sir.
So your charge particle is moving like this. So this is your charge particle Q, and this is the magnetic field. So here the magnetic field is along x-axis. The magnetic field is along x-axis, and here charge particle is moving in this direction. Is the velocity of the charge particle is in this direction, and this velocity of the charge particle is making an angle theta with the magnetic field. In the x direction there is magnetic field, and this magnetic field is uniform. Okay, so what we will do, and we want to analyze the motion of the charge particle. So we will just divide the motion of this charge particle along x-axis and along y-axis, along x-axis or along y-axis.
Yes, sir.
So what is the meaning of x-axis and the y-axis? So see here, we will take the one component of the velocity along the magnetic field, and we will take one component of this velocity. We will take one component of this velocity along magnetic field. We will
Yes.
take one component of velocity perpendicular to magnetic field. So we have divided the motion of the charged particle along x-axis and y-axis, parallel to the magnetic field or
Yes, sir.
perpendicular to the magnetic field. So this is the vector v. We can take the component of this v along this x-axis. This will become v cos theta, and the component of the velocity perpendicular to this magnetic field will be v sin theta.
Yes, sir.
Now we have to analyze the motion along x-axis and the motion along the y-axis. Now this will be removed. Now you can remove this vector because there is now no this v vector. We have just splitted this v vector along x-axis and along y-axis.
Yes, sir.
So there are two components now we have. One is v cos theta, another is v sin theta.
Yes.
So v cos theta is parallel to the magnetic field because the direction of the v cos theta and this magnetic field are same. So v cos theta is parallel to magnetic field. So remember
Yes, sir.
the point when your charge particle is moving along the magnetic field. So this v cos theta is representing that the charge particle, if the charge particle is moving along the direction of the magnetic field or parallel to the magnetic field, so in that case there will be no force on the charge particle if the charge particle is moving parallel to the magnetic field, this case. So there is no force on the charge particle. Here see, this is the first case. This charge particle, this is moving parallel to the magnetic field. Parallel means in the same direction of the magnetic field. Here the force on the
Yes.
charge particle is 0. So the path of the charge particle will be a straight line. So same is the case here. You can relate it.
Okay.
This is the component of the velocity. Means now you can imagine that the charge particle is moving along the magnetic field because this component represents the velocity along the magnetic field. If the velocity is along the magnetic field, then there will be no force on the charge particle, and charge particle will perform the straight line motion. So here you can see the magnetic force Fb represent the magnetic field on the charge particle. Magnetic force on the charge particle will be 0, and path
Yes.
will be linear. Linear means straight line path.
Okay.
Now see this component. This component is v sine theta.
Yes, sir.
This component is perpendicular to magnetic field. Mean you can say that this time the velocity, this velocity is perpendicular to magnetic field. So if the velocity is perpendicular to magnetic field, see here, this case here, this is the velocity and magnetic field is along z axis. So here the magnetic field and the velocity are the perpendicular. Okay, see, charge particle moving perpendicular to magnetic field means velocity of the charge particle will be perpendicular to magnetic field, and in
Yes,
this
sir.
case the charge particle will follow the circular path. So you can say that due to this component of the velocity, the charge particle will try to move along the circular path. So due to v sine theta, this v sine theta is perpendicular to magnetic field, and the force on the charge particle will be there this time, and that is given by qvv sine theta, and path will be circular. Path will be circular, we have discussed. So when you will combine the linear path and the circular path, when you will combine the linear path of the charge particle, at the same time, due to this v cos theta, the charge particle is trying to move in a straight line.
Yes, sir.
But due to this v sine theta, the charge particle is trying to move along the circle. So
Yes, sir.
so there should be a path that should be the combination of the straight line path and the circular path.
Circular
And
path.
that
Yeah.
path is known as the helix path. Means your charge particle is here. Charge particle is performing the circular motion, and
Yes,
instead
sir.
of the circular motion, this charge particle is moving to forward, or charge particle is moving to backward. Means charge particle is moving on a straight line also, or on the circle also. So
Yes,
this
sir.
type of motion is known as the helical motion, or the helical path the charge particle will follow. Helical. Okay. Combined
Okay, sir.
path, combined straight line path and the circular path will be the helical path. This represent the helical path. Means when you are moving
Okay,
like
sir.
this, you are
Okay,
moving
sir.
like this. Like means this means you are moving on a circle also, and you are moving in
Yes,
a
sir.
straight line also. Now there is a term related to this helical path, that is pitch. Pitch is that this distance, this and this distance. This pitch is calculated by, as this is the distance, so we can calculate it with the speed into time. So speed in this direction is v cos theta, and the time period of the charge particle for the circular motion. So v cos theta pitch is equal to v cos theta into time period. V cos theta into time period. So this formula will become p cos theta. The formula of the time period is 2 pi m divided by qb. So this will be your pitch.
Okay, sir.
So this will happen means when your charge particle will move at some angle, and that angle will not be equal to 90, 180 or 0 degree. Then your charge particle will follow the helical path this time.
Okay, sir.
Now you can take this.
Okay, sir. Done, sir. Done, sir. Okay, done, sir.
Okay. So we have discussed that this actually we were discussing about the Lorentz magnetic force.
Yes, sir.
Now we will discuss the combination of the magnetic and the electric force. Means when your charge particle will be in a region where there will be the magnetic field as well as the electric field.
Yes, sir.
So simply you can say in that case there will be the electric force on the charge particle and the magnetic force on the charge particle. Two types of force will be there. If the
Yes,
charged
sir.
particle is moving in a combined electric and magnetic field, then the force on the charged particle will also be the electric force and also be the magnetic force. Simply.
Yes,
And
sir.
this force is known as the Lorentz force again. And this is the combination of the magnetic and the electric force. So, charged particle in a combined electric and the magnetic field. Charged particle in combined electric and magnetic field, the charged particle is moving in a region having the electric and the magnetic field. And I am supposing Q is the charged particle. And I have told you that on the charged particle, the total force on the charged particle will be the electric force and the magnetic force. Okay, now the electric force on the charged particle in the electric field E will be given by this. I am writing this Fe is the
Okay.
electric force. So this will be Q into E vector. And the magnetic force on the charged particle will be Q into V cross B.
Okay, sir.
So this will be the final formula. So your charged particle is moving in a region where electric and magnetic field both are present. And suppose V is the velocity of the charged particle. Velocity. So this is the combined electric and magnetic field. So remember this charge into electric field. Now on first take the screenshot, then I will.
Okay, sir. Done, sir.
Now on this formula, I am taking one numerical. So we will use this formula now. So I am taking this question. Ziyad, are you able to calculate the cross product of two vectors?
Cross product, sir?
Cross product, there is a term, cross product. So see here, this is the charge particle.
Yes, sir.
This is given as 2 coulomb.
Yes, sir.
And this charge particle is moving in a region where electric field is there and the magnetic field is there. Both
Yes,
the
sir.
electric field and the magnetic field is given in the vector form. Now, this charge particle is moving with the velocity, and this velocity also is given in the vector form. We have to calculate the Lorentz force. Lorentz force means combined electric and magnetic force you will calculate. The
Yes, sir.
formula of the Lorentz force is given by this. So total force on the charge particle will be given by Q into E vector
Yes, sir.
plus Q into V cross V.
Because, yes, sir.
We have charge, we have electric field, but we do not have V vector cross V vector.
Yes, sir.
This we will calculate. There is a method to calculate the cross product of two vectors. So first write here I cap j cap into
Oh,
k
yeah,
cap.
I've done this in maths.
Yeah, in maths this is the
Yes, sir.
this is the just a cross product, and
Yeah,
this is
yes, sir.
the this topic comes under the vector, and vector is a math.
Yes, sir. Yes, sir.
Yeah. So
It's cross multiplying, sir.
yeah, so here you will write this here is the v vector. Now go to the v vector. Write the
Yes, sir.
coefficient of I in this row. We
One.
will make one row, two row, and three row.
Yes, sir.
And we will have one column, two column, and three column. So
Yes,
write
sir.
the coefficient of I cap with respect to this v vector. Coefficient of I cap is 1. So
Yes,
here
1.
I will put 1.
Minus
For
3.
j, I will write minus 3.
Minus 3. Yes, sir.
And for k, there is
0,
no k
sir.
here, so 0.
0. Yes.
Now for the magnetic field, I will write 1. Because the coefficient of I cap is 1, so I will
Yes,
write
sir.
1 here. Okay.
And then 2.
2, then 5.
And 5. Yes, sir.
This is very simple. 2 and 5.
Yes, sir.
Now we will do the. Now we will open this determinant.
Yes,
I will
sir.
write here first I cap and bracket.
Yes, sir.
So I will
Yes, sir.
hide this column and this row.
Yes, sir.
Okay, I will hide this column and this row. So I will have this thing.
15, sir.
Yeah, I will have this.
15.
So this will become minus 15. 5
Yes,
into
sir.
minus 3.
Yes,
So
sir.
this will
Minus
become
15.
minus 15. And here I will write minus
0, sir.
sign. 2 into 0 will become 0.
0.
Very good. Here
Yes,
is
sir.
I will write minus j cap.
Minus j
And
cap. Yes,
for
sir.
j cap, I will hide this row,
So
this
5,
column.
sir.
Yeah, this column and this row. So this will become 5
5.
and this will become 0. So I can
Yes,
write
sir.
here only 5. Here
5. Yes, sir.
I have this k cap. So for
Yes,
this
sir.
k cap, I will hide this column and this row, and
Yes,
we
sir.
will have
So minus 2,
2.
sir.
Yeah, this will become 2 and this will
Yeah,
become
2, sir.
minus and this will become minus 3.
Yes,
So
sir.
finally you will have minus 15 of I cap, and this will have this minus 5 of j cap, and
Yes,
this
sir.
will have minus, this is 2
So
minus
5.
minus plus, this will become 5 of
5k.
k cap.
Yes, sir.
K cap. So v cross b is this. Now we will put all the value in this formula.
Okay,
We
sir.
will put all the value in this formula and we will get the answer. Now the things are simple. So
Yes.
total force is given by charge is 2. We will put
Yes,
the
sir.
value of electric field. Electric field is given by I cap plus 2j cap.
Yes, sir.
So I cap plus
2j.
2j cap and plus charge is 2. V cross B is this.
Yeah, okay, sir.
Minus 15I and minus of 5j
Plus 5.
plus 5k. So simply now you can multiply simply this 2I, this will become 4j.
4j.
This will
Yeah.
become 2I cap plus 4 of j cap, and now
Plus
here you
minus
can
30.
multiply this will become
Minus
minus 30.
Yes,
Minus
sir.
30 I cap, this will
Minus
become
10.
minus 10 j cap, this will
Plus
become
10.
plus 10 k cap. Now
Yes,
add
sir.
I cap with I cap, j cap with j cap, k cap with k cap. So 4 I cap, this is minus
34.
30.
Yeah,
30. So
so
this will become minus 26.
yes, sir.
Minus 26 I cap, and this is 4 j cap, this is minus 10 j cap. So this
Yes,
will
sir.
become minus 6 j cap.
Minus 6j. Yes, sir.
And what about the k cap? Here is only one k cap, so this
Yeah,
will
so
become
plus
10 k cap.
Yes, sir.
So this is the force in the vector form. So this is the final value of the force.
Yes, sir.
This is your final answer of this question.
Yes, sir. Yes.
So in this way you can solve this question. Just a minute. Now take this.
Okay, sir. Done, sir.
Then
Done, sir.
so this thing is completed now. Now I will discuss. Suppose you have a current carrying wire. This wire you have. This I suppose this is a wire, a straight wire you have, and this wire has some current in this. So you have placed this wire in some magnetic field. Then what will happen? Then what will happen? Earlier we have studied what happens when a charge will be placed in the magnetic field. Now you are placing the whole current carrying wire in the magnetic field.
Yes, sir.
Okay, now see what will happen. This current carrying wire have the current, and
Yes,
this
sir.
current carrying wire have the charge carrier inside it.
Yes, sir.
Charge carrier means these current carrying wires have the free electrons as a charge carrier. So what will happen? You can imagine this current carrying wire as charge carriers are moving along the direction of the current or
Yes,
opposite to
sir.
the direction of the current if you are uh, taking the electrons, because electrons, if the direction of the current is from in this direction, upward direction, then the
Yes, sir.
direction of the motion of the electron will be downward direction. Okay.
Yes, sir.
So you can imagine a current carrying wire as the charge is flowing in the magnetic field. Okay, as we have placed the wire in the magnetic field. So there will be some force on that. So you see
Yes, sir.
here, this is the magnetic field you have. This is the uniform magnetic field. And this is the wire. This is a wire, and this wire have the current I. And
Yes, sir.
length of the wire is this L. Length of the wire is this L. And this length of the wire, or the wire, makes an angle theta with the magnetic field. I am supposing capital A is the area of cross section of the wire. So suppose this is a wire, so this will be the area of cross section, this thing.
Yes, sir.
So L is the length of the wire.
Okay, sir.
So you can say that current carrying wire, this is a current carrying wire,
Yes, sir.
have many charges inside,
Yes, sir.
and these charges will be in motion. Like in the drift velocity, we have studied that we have the electrons in the conductor. When the current flows in the conductor or the wire, then what happens? The electron starts moving with the drift velocity. So here also there are electron inside. When you will apply the electric field, there will be some current, and due to that current, the charge particle inside will be in the motion. So you can now imagine that there are the charge particles which are moving like this along the direction of the current. The charge
Yes, sir.
particle are moving, and if you are not considering the electron, in actual there are the electron which are moving in the opposite direction of the current, but I am considering here that here is a charge particle, here is a charge particle which is opposite to that of electron, is moving in the direction of the current. So here L is the length, and what I am taking. So you can say that this current carrying wire have many charges inside are in motion. Is it or not? There are the charge carrier inside the wire.
Yes, sir.
When a moving charge is in the uniform magnetic field, we have discussed earlier, when there is a moving charge will be in the magnetic field, the charge will experience the magnetic force. The
Yes,
charge will experience the magnetic force, and that magnetic force is given by qvb sine theta.
yes, sir.
Given by q. Now what I am doing, I want to calculate the total force acting on this wire in the magnetic field. So what I am doing, I am taking very small region of this wire. This region is very small. This region have the length dl. Dl is very small length of the wire, or you can say an very small element of the,
Okay,
and
sir.
this dl length have the cross section area A, because this is a cylindrical wire. So throughout the wire, the cross section area will remain same. So I am
Yes.
just first calculating the volume of this DL region.
Okay, sir.
So first calculate volume of DL region. DL region means this region, and this region is very small, and the volume of DL region I will represent with dV, and this dV will be, what is the volume? Volume is uh, length into area. So what is the length of this
So
element
volume of
DL?
cylinder.
Any volume is
Okay.
okay. See, suppose you have the cylinder here.
Yes, sir.
So if you want to, suppose L is the length of the cylinder,
Yes.
and here area of cross section is this here. Okay.
Yes,
And
sir.
here is the circular cross section, so area of cross section will be pi r square. R is the
Yes.
radius. So if
Yes,
you
sir.
want to calculate the volume, so just write A into L. So area is pi r square into L.
E-
So this is the way
Okay,
to
sir.
write the area or volume. So volume is length into area. You can write dl into A.
Yes, sir.
So, or you can write this A into dl. Area of cross section into dl. This will be the volume. So you can imagine this will become a very small cylinder. Suppose this is the wire I have, and I am taking very small length of this wire. Suppose I have taken the length of the wire from here to here. So
Yes,
this
sir.
cylinder will become, this thing will become a small cylinder this time. So this
Yes, sir.
cylinder has some length, and this cylinder also has some volume. So that
Yes, sir.
cylinder I have taken, I have cut it one very small length. And suppose in this region, capital N is the number of E positive, okay, E positive charge carriers. Okay, and now see what
Okay,
is
sir.
E positive I have represented. So E positive is a charge carrier moving in the direction of the current. E positive is a charge carrier moving in the direction of the current. I have just assumed. And this
Yes,
E
sir.
positive will move with the drift velocity. E positive is moving with the drift velocity. Okay, and I have taken one more term here, n, small n. Small n is the number of charge carrier or number of E positives per unit volume. Means if we will take 1 meter cube or unit volume of this wire, then number of charge carrier will be small n. So this is the meaning of number of charge carrier per unit volume. Means in a unit volume there are small n number of the charge carrier.
Yes, sir. Okay.
So now we are interested to calculate the total number of charge carrier in this region, and that is n. N is the total number of E positive in DL region. So
Yes, sir.
total number of charge carriers, that is E positive in DL region, and total number of charge carrier, this thing is represented by capital N. So this capital N will be given by A and ADL. How I have written this? See, for the unit volume, you have a small n charge carrier. If
Yes,
you
sir.
want to find the charge carrier in this ADL volume, then you will multiply this small n with ADL
ADL.
simply.
Okay, sir.
Now we have capital N, that is NADL. We have this. Now we have just calculated the total number of charge carrier in this region. Now we will
Yes, sir.
see that what will be the force on all the charge carrier present in this region, because we know that charge carrier in the magnetic field will experience some force.
Yes,
See,
sir.
so you can write force on all E positive in elemental region. Elemental region is also known as DL region.
Okay, sir.
DL region. And this force on all charge for uh, carriers will be very, very small, because here this region is very small. So charge carrier will also small, force will also small. So this force, small force, will be represented by df, and this will be equal to charge. Now I have to explain you something. For this thing, force on, we will calculate force on 1 E positive. Force on 1 E positive. And remember that this E positive is moving with the drift velocity. So the what will the force on 1 E positive? Charge into
Yeah.
drift velocity into magnetic field.
Yes, sir.
From this formula, charge into
Yes,
velocity in
sir.
the magnetic field, because
Yes, sir.
this E positive is moving in the drift velocity, so I have written this.
Okay,
So
sir.
this force is on 1 E positive. Now, can you tell me, if you have this number of E positive or charge carrier, so what will be the total force? Total force on all E positive in DL region is equal to capital N and force on 1 E positive. Okay,
Yes, sir. Okay, sir.
simple
Yeah, okay, sir.
multiplication. This is,
B vector.
or you can open this also. This will become E into VD into V into sine theta.
Both are correct, right, sir?
Yeah, this is also correct. This is, I am just opening it because I want to solve some thing. Okay.
Okay, sir.
Sometimes it is required to open this vector product because we want to simplify the expression. So this will
Okay, sir.
become E into VD. VD represents the drift velocity,
Yes, sir. B sin theta.
and there is one note here. Okay, in the last we will V suffix D
Drift.
is
Yes.
the drift velocity.
Yes, sir.
Drift velocity with which E positive is moving. E positive is same as that of electron, but the direction is just opposite to that of electron. Now put the value of capital N. So total force will be dF, and now put the value of this capital N. NADL.
Yes, sir.
This is capital N, and this will be EVD B into sine theta. Now there is a relation between the current and the drift velocity. There is a relation between the current and the drift velocity of the wire of having cross section area I is equal to A and E into drift velocity. A is the area of cross section of the wire.
Yes, sir. And
N
N
is
is
the,
the
yeah, N is the number of charge carrier per unit volume. E is the charge on the electron, and VD is the drift velocity.
drift
So
velocity.
instead of the electron, I am taking a charge carrier similar to that electron, but direction
Okay,
is
sir.
opposite. So
Okay, sir.
this DF. So now you have this A N E V D. So this is A, this is N, this is E, this is VD. This
Yes,
is
sir.
A N E into VD. So this will become current,
Okay, sir.
and
Oh.
this A, you have this DL you have this B into sine
I,
theta.
ideal B sin theta. Okay.
Now this is the force on this dl length. If you want to calculate the force on total length, you will integrate this.
Okay, sir.
You will integrate this. So okay, Ziyad, I am just leaving it here, and we have come. Okay, I am just completing it. Integrate this equation.
Yeah, okay. So ideal B
Ideal.
cos, right?
No, this time not cos. Because
Okay.
what will happen? Okay, this thing we will discuss in the next class. Okay.
Okay, sir.
Okay,
Okay.
I'm just leaving it here because there is no time. Okay, just take the screenshot.
Okay, sir.
So this derivation is now I have completed to 90%. 10% is
Okay.
remaining. So tomorrow we will discuss. Inshallah.
So